Hello everyone, in this video we'll see tree height. Here we have an N-ary tree and we are going to find out what's the height of the tree. The tree is always rooted at the node 1. So from node 1 we have to traverse all these nodes and we have to find out what's the maximum height of this tree. Maximum height is this is one height. This can be a branch but this is literally named as height. So here you have the longest branch from the root. So this is called height. Let me download this and bring it to here. I will upload this one here. So the height of this tree is 1, 2, 3, 4 and 5. From root we have to traverse. This is 1, 2, 3, 4 and 5. So we don't need to print this path, we just need this number like 1, 3, 5, 4 like this and all. We don't need, we just need the number 5. So how do we achieve that in C++? I give one more example. This is for 5 and here you have one more tree. I'll copy and paste, arrange as tree. In this example you have 1, 2, 3, 4, 5, 6, 7 and 8. There are 8 nodes are there, so the height of the tree is 8. So how do we achieve this? In user input we'll give the number of nodes and we have n-1 edges, so u and v will retrieve, and then we have to form the tree and then we have to write a function to do this. Okay, how do we do this? First of all, we'll see the implementation later, but we just understand how do we solve this problem. I'll write the program here itself first. So we should have a function. How this function is called is tree height, and I'll reduce this font to 14. 14 is too small, so I'll increase this to 64. And this one is left and at the top. So we should have a function, and this function name like height of tree, and how do we do this? As first we have height. First, when you given as a 1 from the function call, it will start from this root node. So 1 will be the starting node. I told earlier in the problem itself, it will always starts from 1. So 1 is there, and then it has to go to the next node. Next node means it has to find all the child nodes. Here it is a directed graph, so you can see this lines are going like this. So you can treat this one also a directed graph. It will be like this. So I need to change 6 to 2, 2 to 6. Here you can see this links are directed. So how do we find the adjacent? Is we have to give a for loop and we'll get all those adjacent nodes. That's what we used to do. So once I get the adjacent nodes, here I'll get int height as 0 I'm starting from this node, so here itself I'll not have any height, so I have height 0 in this node. So here I'm giving that height as 0, and then I have the adjacent nodes. So what are the nodes are connected to this? So we have only 3 nodes. So what I do is I have to write like for all the nodes, auto is like an iterator, and we have a vector of int a in this function as a parameter. Here you have to give this root node. Root also we have to receive from the function call. So we got this. So we in this line itself we can go and iterate all those adjacent nodes. So here itself, or I just shrink in this or move this. And yeah, inside of this for loop, once I reach this node 1, again it's kind of a node structure, so it should go inside, which means it has to make a recursive call. So what I'm doing is here itself, this line I'm inserting one more line for recursion. So how that looks like is, I have to call height of the tree and have to pass the same a, and now the root is v. So we have to switch to this 3. So how do I do this is I directly write this auto v, and here in this function itself I have to return some numbers. So as a height, so I'm returning it as height plus 1, because this is itself as a height. This when we visit itself, this one is an height. So we have height of tree which passes the adjacency matrix A itself, and each node it is passing as B. And next in the each function recursion calls, so it will be like a height will be there. So once I move to this one, the function call is there, and then from 3 again it is a recursion call. So again 6 it is a recursion call, again to 2 it's a recursion call. So once it's in the leaf node, you can see it will not at all go in this function because it does not have any adjacent nodes. So from here what it returns is height plus 1. So here nothing is there, height it's 1. And then when the stack trace will have this function, once it completes from the 2 it will have 6. So again when it goes here we have to find out this height is actual height or whatever calculated underneath this node should be calculated. So what I have to do is here I have to find out which is maximum, which from whatever adjacent node below this 6 is it greater or this height is greater. So I have to write a max. So here max of height comma that's assigned to height itself. I hope you understood this line. I just erase this all these marks. So here you have to understand is only this line. Why we write a recursion? You have completed traveling deep inside of this node, and leaf nodes you're entering it as 1. It will not at all enter this for loop. So we are just returning it as 1. Here only this is there, so it's namely 1. And then when 6 is there, we are comparing against what is being returned from this node while traversing the recursion call against your height. That's max is 1. So in this every functions will return plus 1. Here it will be 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. So ultimately it will be 5. How do we convert the same thing into programming is you have to write a vector for the adjacency list int, and inside of it I'm marking it as a 100 and node as int n. I need 2 edges, so I'm writing it as u and v. Format the document for how to get n, and before that you have to see in n. You need to get n minus 1 edges, so c in u v. Here you're writing as a directed, so a of u dot pushback v, and your graph is your tree is ready. Now you have to call a function. Before that you have to declare that function int. I'm writing as tree height. You need as a reference vector int a. Here no need number, and int root. And anyhow you have variable called int height. I have to initialize to 0, and in each functions I have to return the height plus 1, because when you visited this node itself it's treated as 1. So I have from 0 I am incrementing it by 1, and when I visited a node I have to travel all the adjacency lines. So here in this example you can take a big tree. You can give it as 6 and 2. In this example you have 3, and here it will have adjacent nodes 4 and 5, because that's the reason we are writing. For you need a pointer, so I'm automatically writing as R2, and I'm writing as V. And how to find adjacents means you have to write a of root. Okay, now how to make a recursion call in this one, because each and every level is treated as node. So I'm writing as tree height. Here the same AR I'm passing, and here instead of v I'm treating the current node as root, and I'm passing. This one will returns an integer of height, so I'm assigning this height to find the maximum of it against my current height, and the result I derived from the subtree. So I'm just formatting the document. Here in this one you have to write C out. Here height is tree height, and how to pass this a and pass this root as 1. Okay, have a, you have int uv, derived all those u and v, and see out height, tree height, it goes to the tree height. It's initially 0 and it'll always goes inside of it and assigning to height and return the height. Okay, now I'm running the code. So now I copy my test data. In this one you have 6 nodes and 5 edges. Run. The tree height is 5. This tree is nothing but this one, 1 2 3 4 5, and for this one it is 8. I'm just copying the same data, copy and run. So the tree height is 8. So 1 2 3 4 5 6 7 8, 8 nodes are there. So our code is successfully executed. I hope understood this problem. In this problem, you at most you have to get it is just this one line, why this recursion takes place and why we are adding this height plus 1, and that's it. So hope you understood this problem and solution, and we'll meet in the next video. Thank you for watching.